Hello, everyone. Bonjour. My name is David. I'm David Catiu. I'm working for Microsoft DX, and my focus is on the open web standard, and obviously project Microsoft Edge. I will do that all along this session, trying to not saying Microsoft Spartan and just saying Microsoft Edge. So please bear with me. I'm here with David.
Hello, so I'm doing more or less the same things, and I'm working as a senior program manager on the same staff.
So yeah, today we will present you the inner core of Microsoft Edge, and mostly we will try to focus on new features that we added on it. And we just want to do a little introduction before to explain you why a new browser, what's inside, and then we'll go to do some coding.
And a lot of demos.
Yep. So please submit an evaluation. There are some prize to win. Just use the QR code here. I think you are used to that. So the agenda, 3 parts. Why a new engine? Then what modern web interoperability means today. And obviously, we will focus then on features and code. Just a quick poll. Who is a web developer? I love you guys. I love the other one, obviously, as well. But that's a big bunch of people. And I can remember that last year, when we asked this question, it was like perhaps 20% of the room. And I think it's like 50 now. That's a good evolution. So first question, why creating a new engine? Why creating a new browser? So to just give you a little bit of vocabulary, here is how a browser is working. We have the window itself, what we call the Chrome, but that's not easy to use when we deal with browsers, so let's call it a window. And inside that window, we have the web platform itself, meaning the DLL and all the C++ code that handle all the things related to HTML, JavaScript, CSS, in order to render a picture of your page, okay? For IE, the name of the web platform is Trident. We have, obviously, the same story for Chrome, and the name of the web platform this time is Blink. We have WebKit for Safari, and we have Gecko for Firefox. But we all work the same way, a window and inside a web platform, okay? A rendering engine. Just a little bit of history. 20 years ago, we started in 1995 with the very first version of Internet Explorer. 20 years ago, when we talk about computer science, it's like dinosaurs. At that time, we created the very first version. But let's just move to IE6. IE6 was the very first version where we introduced a new toy, the Bang doc type. It was an idea for us to address, in the same time, new features and backward compatibility. We wanted to add a lot of new features inside IE without breaking the web. Okay? So we said, okay, let's consider if the web developer put a Bang doc type at the very beginning of the page, we consider it's a trigger for us to use the very new feature that we added in IE6. Okay? But because we don't want to break the web, we also support the previous version, like i5, etc. Okay? We call that the doc mode, document mode. The doc mode, it's a compat flag inside our code that turns on and off any specific feature we have. We can just imagine that inside IE code, there are dozens of if. If IE6, then I can do that. If IE5, then I cannot do that. Okay? And for IE6, we had at that time, inside the same engine, 2 doc mode. Okay? So a combination of 2 if, actually. If this for any version, then we can do that. If not this specific version, then we cannot do that. Moving forward, let's go to IE8. With IE8, we introduce a 3rd document mode. Same story here, actually. We took this concept further, 3 document mode, so more if inside the code. Always keep in mind that we wanted to provide new features without breaking the web. Okay? And then, let's move to IE11. Guess what? At that time, we knew that there were a problem. it's not possible. And you know that the developer that created IE engine were really brave guys. Let's imagine we have a bunch of if IE11 and not 10 but 8 and whatever. It was just really complicated to do. But we do that because our focus at that time was compat, backward compat. Okay? In the same time, Chrome, Firefox, Opera, Safari are what we call evergreen. That means they just have one specific version. They don't have if Chrome 31 or if Chrome 32, whatever. They just have all the features always available. And they are updated quite frequently. It was not a fair game for us. So we decided to introduce a new browser. The idea is pretty simple, actually. Let's keep IE11 for backward compatibility. We won't touch IE11 anymore. But it will be here under the hood if required for enterprise or for specific features that are not supported by the modern web. We call that the legacy features. We don't want to break the web, but we want to go and to provide a better experience for our web developers. So let's introduce Microsoft Edge based on a new DLL that is a fork of Trident, and I get back to that after, and that will span across all our Windows 10 devices. And you can see here, we will have, not Spartan, but Edge on your Windows Phone, on your tablet, on your PC. And that's something I really love, to be honest with you. And talking about the new browser, obviously we need to talk about interoperability with the web itself and with other browser vendors. And David, can you give us more information about that?
Yes, so today when you are using the web, addressing the web, here is the variety of devices you can target. So it's huge. So it's tablets, PCs, phones, TVs even. So there's a lot of them. Fridge, yeah, in your case, fridge, that's right.
I have a connected fridge, yes.
And the idea is then to write once and to run everywhere. This is a dream. Then you see that there is a specification. So writing specification as browser vendors is a bit complex. It takes time. For instance, the HTML5 specification is more than 600 pages to read and to review. So we are doing that. We are writing browsers together, but the web developers sometimes are not reading the specification.
Sometimes.
Which I can understand, yeah. But it works well most of the time. On the desktop part, for instance, if you have a look to this site, now if you're using modern version of Firefox, Chrome, or Internet Explorer 11, or today Microsoft Edge, well, most of the time you won't have much problem building the website for all the desktop browser. So on the desktop side, I guess the dream is there.
Almost, yep.
Almost. Let's switch to the mobile version. On the mobile space, you can see that the same site is being run on Firefox OS, on Safari Mobile, on an iPhone, for instance, and Internet Explorer 11 on Windows Phone. And you can see that there is some various rendering problem. And let's try to understand why we have these problems.
Absolutely, David. So we have this problem. We try here to capture, it's not scientific, it's not something proportional or whatever. It's just a way for me to explain to you how the web is working. We have browser vendors, and they have their own implementation of some specific stuff. But most of the time, we try to work on what we call the core, the interoperable intersection, where the web just works everywhere, okay? When we think about the mobile web is a little bit different because most of the time, web developer created mobile website for WebKit. And it was a little bit complicated, even for Firefox and IE, to go this way. So here comes Edge. And for Edge, the very first thing that we did was to get rid of all the specific IE stuff we had. So we remove this blue part at the bottom. Think about attach events. Instead of using add event listener, we add back in time attach events, which was just for IE. And I can see, even today, even on jQuery or things like that, I can see if attach event, then use attach event. Instead, if it's not present, then use add event listener. We remove that. We just want things that work everywhere. And then we added a lot of interoperable fixes and features to ensure that our connection with the interoperable intersection is bigger, okay? So David, if we can just think about the web standard here, Microsoft obviously worked toward web standard. That's the way of working. But as you mentioned, we have to be pragmatic. And the way of things are working and the way of things should work, actually, is that web developer should guide the spec. So what we decided was to be pragmatic, as I mentioned before. We will work with web standard, but sometimes we have to update or align specification. Sometimes we will have to fix libraries out there. Sometimes we will have to provide bug feedbacks to other browsers, and obviously, anytime we want to work, we will fix our own browsers. The way we want the web to work is it should just work. You open a web page with Edge, it should work, okay? And obviously, as I mentioned before, we can provide bugs to libraries or any browser vendor. So it's not just about us, actually. It's also about how we are seen by others.
So let's review some samples to give you an idea how we've managed to fix some of the things quite easily. Let's review the page on the left. It was before we introduced some of the fixes for our rendering engine. So it was running the 4.com on Windows Phone and IE. And it wasn't working well because on the website part, people have probably think of the user coming with iPhone or Android, and I was doing like something on the web server. If it is Android or if it is WebKit, then please provide the mobile version of the website. If not, then provide the desktop version of the website. The problem for us is that IE was a mobile version of IE running on Windows Phone, and we added then the mobile, not the mobile version. So to change that, we just introduce a specific way we found a skeleton key in the UI, in fact. So the way is just to say that we are not only IE, we are also acting like Safari or Android, and the way that the web server code will think that we are an iPhone and an Android devices, and will serve us the content for the mobile. And it will going to work directly because there was no problem on the rendering part or JavaScript engine. It was just some bad detection on the server side that was breaking the rendering on the mobile version. So we decided to change our user agent. So I guess you all know user agent strings. And let's go back in the history again. So the first one which introduced it was Netscape, and using the Mozilla 5 version. And everybody has been mixing all the stuff. So we are all playing the same game. When Chrome entered the game, they decided also to introduce the like gecko things to have the Firefox version of the code if the web server was sniffing that. And today you can see that everybody has been copy-pasting the different versions. So the idea is really not to do that anymore and to use some feature detection rather than sniffing the UA. So some other interesting things. So here is another website that wasn't working well on IE11 on Windows 8.1. And the main problem was due to the fact that the code was using some prefixes. So prefixes were used to enable you to test some new features. So for instance, here, the website was using the dash WebKit transition version. Problem is that WebKit is not being used by IE, obviously. We're using a Trident, as we were saying. So to manage to solve this problem, we decided to alias some of the WebKit specific features, CSS, to the standard version being used by IE and today Microsoft Edge. Just by doing that, then we've been fixing a lot of problems on the web because the code wasn't updated to the last version of the specification, and we were using the last version of the specification.
Yeah, that's an interesting point here. It was working, the web rendering engine was working, but we were not receiving the right dash something. We were receiving not dash MS or nothing, so it's really the problem here.
So the idea when all the browser vendors was thinking about letting you playing with some new features was to use prefixes. Well, it sounds like a good idea at that time. But now the new version of using experimental features would be to use rather the about flags things like you can have in Chrome or now in Microsoft Edge. So just by tapping that in the address bar, you can enable some experimental features. So, if the user don't have that in the browser, it won't break. And if the feature becomes then standard in the final version, we will remove it from the about flags.
And you won't have to change your code.
You won't have to change the code, and we enable it by default. So how could you, well, you may pay attention to some other things. So first, please don't do US sniffing, do feature detection, which is really important, because by default, you have to think that a new browser and unknown browser are good by default. So let's imagine that today, I don't know, Mozilla write a new browser with a new name and a new user agent. Let's consider that by default it will be good because it will be modern, so you don't have to sniff it. And please fill some bugs. So we are all filling bugs today. So you have a bunch of bug base you can fill. So at Mozilla, at Google, and now you can also send us some bugs to tell us that's a problem we may have in our rendering engine, just by sending some simple code, like on GSFiddle or CodePen, and we will review it and try to fix our engine.
Yep, so enough about story and why we did that, and more about new features that we added. So, just a little point before, one engine with no dock mode means faster pace. That's obvious. We won't have to spend time testing if all the bunch of if we had in back in time is still working with the new feature we had. So that's easy for us. And here is a new feature that we are working on. It's just an extract of the status.modern.ai website. It's our roadmap. What are we working on? What is already done? Everything here is public. You just have to go to status.modern.ai to find a lot of stuff that we did. We did millions of new stuff just to ensure that the part in the interoperable section is working well. We had new features. We did fixes for interoperability. More about it, just go to status.modern.ai. You will find every information that you may want. And also, you will find things that we are working on and things that we are considering so far. So just waiting for a good reason to implement them. So let's have a look at what is possible today with Edge. Okay? So I'll switch to the 6. The very first demo I want to show you is this one. This demo was developed with a friend of us, Michel Rousseau, who is a designer, a 3D designer, and who did for us the 3D object inside 3ds Max. No plugin, only Microsoft Edge. This features WebGL, Web Audio, and Gamepad. So let me just enable the Gamepad here. Find the Gamepad somewhere.
The right Gamepad.
Yeah, because I think it's the right one. Yep. And can we just turn off the lights? Is it possible? Perhaps no. Sorry. Try to go there. So this demonstration ran on my little X1 Carbon. It's an Intel HD card, so one of the less powerful we can find out there. And we can see that we are running at 60 frames per second with web audio running to give you this wonderful atmosphere, we can say.
And what you can notice is that the sound is currently following the camera. So based on the camera web you're looking at, Web Audio is going to compute everything for you. So you will have the feeling to have some 3D spatialization stuff. It's really easy to do it. We will see that together. So for instance, if you're going there, you can hear the marvelous skeleton playing some pianos. And if we move away from the skeleton, automatically there is a specific distance being computed by Web Audio. You won't hear the sound anymore. And then you can move to the cemetery.
Cemetery, yep.
Yeah. And we have some fun stuff over there.
So for instance, we found that Clippy is dead. We found his ghost.
I mean, I don't know if you remember Clippy. Who knows Clippy in the room?
He's there.
Yeah.
So rest in peace, Clippy.
Maybe you know the
Schrödinger cat.
We don't know if it was dead or not, so we now know it's
dead. That's the good answer. And funnily, we found that I6 is dead. And now, long live to Spartan. So this the main goal here is to show you that without any plugin, just web, we can do really awesome stuff like any native application, actually.
Just imagine having that in full screen. Nobody will probably know or notice that this is HTML5 running and JavaScript code, so it's pretty cool.
Yep. Another example we demonstrated yesterday during the keynote is Flight Arcade. Same story here. Can you please get... OK, so I'm just a dumbass at this specific game, so sorry. Same thing here.
Are you ready to fly? Use the right and left arrow keys to turn.
Sure.
And the up and
Let's do
down
that.
arrow keys to climb
He's
or
really bad at
descend.
playing this game, so I
If you
guess he
have
will
a
lose in
gamepad
approximately
controller,
10
that
seconds.
works too.
Let me avoid to crash here, and let's try to...
See that ring in
So
front of us?
WebGL is not solving problem with the players. So if you're bad players are playing games, so
But thanks. Here we have DOM to render all the UI. Inside the DOM, we have the canvas to render the WebGL stuff. Web audio is used to do the sound. We have gamepad support directly without any specific plugin. Once again, that's just awesome.
And finally, let's move to something else. So everything has been built on top of our favorite engine, which is Babylon.js, an open source WebGL framework. So this is the thing we've showcased you during the first keynote. So it's running, it's the Pompeii city that has been rebuilt using some drones. So we take some pictures of the city and rebuild a complete 3D mesh that's really used with a lot of textures. And we are using, if I don't know if you're a 3D expert, what we are naming the load. So it's a way to load the various versions of the mesh based on the distance you are.
We have more than trillions pixels here because the drones were able to capture 1 pixel for every 2 centimeters. Sorry, centimeters. I hope you get it. I don't have the translation in...
And you see we can move in a city, and everything is being computed in real time. And the city is really, really huge, so, and everything can be run now in the browser. So using the gamepad now and WebGL, you can fly over the city, and you can move near some of the stuff, and we will load some higher definition meshes and textures. And you see it's pretty cool to imagine that this is available immediately. If you go to the specific web server now, you can have this kind of experience running in a browser with no plugins at all. So we thought it was some really cool demo to demonstrate you, and now we need to show you how to
do that.
How to do that.
So let's switch to your computer, which is a 5.
And let's start by talking about web audio. So web audio is a way to attach some sound and to put some sound in a 3D space or not. It's based on the routing graph. So you got some specific audio nodes that are going to connect together. And those nodes could have some impact on the volume, could have impact on the 3D spatialization. You could have impact on filters. You can have some low filters, some high filters. You can slow down the music. You can speed up the music. You could do whatever you like you can imagine in games, for instance, using web audio. You could create some sound in a procedural way, so it's really impressive. So I'm going to show you something we've got on our Babylon.js website using web audio. So just let me enable the sound. So this is all, I've been composing the music, so sorry for that. It's going to be very boring because it's a loop. Just to show you that we are loading a sound here, and we're going to ask to be looped and to autoplay it. And I'm binding it to the web audio stuff I'm going to show you. And then I'm going to attach this music to a specific 3D objects. We call that a mesh. And by doing that, I don't know if you're able to hear that in the room, because you need, most of the time, a headphone. But the current box is moving all around my head. And thanks to web audio, I can hear it on the right, in front of me, and then on the left, automatically, without doing any computation on the JavaScript part. This is being handled by the browser and by the API itself. So let me show you the code. The first things you need to do when you want to create some web audio stuff is to create the context. So if you are a JavaScript developer, maybe you already know about 2D canvas or WebGL canvas, so you need to create the context. So the way to do it, so we were talking about that just before. The standard way is to create the audio context on the window object. But as Chrome was the first one to introduce it, they introduced it using a prefix. So you may pay attention to that. So they are about to remove it in the next version. So in the meantime, you need to test both versions. Is it the WebKit version or the unprefixed version? Once you've been able to check that this is existing, you can then create it and create some specific nodes. So for instance, a gain node is more or less the volume you will have. And then you will be able to connect it to a destination. Destination could be some speakers, some headphones, or if you want to write the sound down on the disk, for instance. So you're connecting nodes like that together. Then, when you want to create some specific things, you need to set up some specific other properties. Let's think, for instance, about a painter. A painter node in web audio is a way to do some 3D stuff in the audio spaces. So let's say that you want to create 3D sounds, so you need to create a painter to connect that to your audio node, to your source node. And once you've done that, you have to choose the way the sound will behave in the 3D space. So let's say that I want the sound to stop after 10 meters in a linear way. I can set up that in the engine by setting some properties. So you need to understand a bunch of properties. And here in our gaming engine in Babylon.js, I've decided to set up some default properties to avoid letting you understand how it works. So based on that, what we decided to create is a funny experience. So I need to reload it.
How are you guys?
You can talk while it's loading.
Yes. This is Visual Studio.
And let's launch that. So not in IE. It's already in use. OK. So let's. This one.
Are you sure it's already in use?
No, it's not already in use.
Retry?
It's going to work, I'm sure.
Yes, we have time. This is AI.
Refresh.
That should work. Yes, good.
So the idea, remember that I showed you a cube that was moving around my head. I've put some sound on it, so I reuse the same principles. So rather than updating the position of the sound based on the camera itself, we decided to update the sound based on the distance you are from the center of the circle. And on each cube, I've decided to put some specific music I've been composing. So it's several tracks of my music. And when I'm moving one of the cube near the center of the scene, it's going to pump up the volume. And when I'm removing it from the circle, it would stop the sound. So the idea is to let you mix sounds using the cube. So we found out it was very, very funny. And thanks to the pointer events being used by i11 and by Microsoft Edge today, you can have multi-touch experience in a very easy way. So I need several fingers.
Yes.
So I will ask you some help. So for instance, let's move some finger. And we can then create the music together. Like that. And then reuse the mouse. And we can even do, you see, you can ever attach some of the cube like that. So I'm going to do the stupid joke because maybe you noticed that we have a strange accent.
You're
yes,
so
and I've got some problem to building my own flags. And you can write the French version of the music like that by building blocks together and putting that in the center of the scene.
Thank you, David. Let's switch to mine. Let's switch to something completely different. I want to show you the CSS filters. This is something I really love. CSS filter is a way for any web developer to add post-process effect using shaders on any DOM element. And to show you this example, I have this reading page. I want to read my text, but you know I have this wonderful dragon. I'm a big fan of dragon, if you didn't notice. And I don't want to remove my dragon. I want to keep my dragon, but when I want to read my text, I want just to remove all the distraction. You know, we can find that in a reading view or whatever. So what I'm doing, when I'm hovering the text, I'm just applying a CSS filter on my div element on the back. So I can just easily read my text. I have the opportunity to also use grayscale and blur together. We can mix CSS filters together, so then it will be blurred and grayscale. And obviously, I can play. It's dynamic. It's 60 frames per second, and you can control it easily. So let's just have a look at the code. And for that, I'm using Visual Studio Code. I love this tool. I just uninstalled Sublime Text. So what we have here is pretty simple, actually. I just have my text here in this content, and I have my background, okay, here. This is the div where I put, using my CSS rule here, I put just my back.jpg image inside, okay? And what I want to do is, when I hover my text, I want to apply this. It's a CSS rule that say, okay, let's use the blur effect with that size of blur. And because I'm working well, I'm using prefixes version and unprefixes version as well, just to be sure I won't have problem in the future. Okay? So from the point of view of the JavaScript code itself, that's pretty simple. On mouse over, I apply the CSS rule. On mouse out, I remove the CSS rule. That's it. And another example that I'm doing when I click on the grayscale object, you can also control it, obviously, directly from JavaScript by saying, I want blur and grayscale. So you can mix all the effects. You can do convolution, sepia, whatever. You can play Photoshop-like effect dynamically, and it's hardware accelerating using shaders. So that's free to use. Please do that. The main problem we may have is that sometimes CSS filters may not be supported. So this led me to another demonstration, David.
Yes.
This one. This time, let's just show how it should work. So as you can see here, I have always the same result, okay? But what happens if CSS filters are not supported? And to simulate that, and to show you as well how the flags are working, I can come here and say, okay, so far the CSS filter is an experimental feature. And I want to not use them, just to see how they could work if there is no CSS filter, okay? So I just have to do that, relaunch my browser, switch to support here, and I have another behavior. This time, because CSS filter is not supported, I'm just playing with the opacity of the picture and setting it to like 0.1 so we can see the background. How to do that without any code, any JavaScript code? That's the cool question I ask. I have just to use a really cool new feature called @support. @support allows me to test the presence or the absence or any CSS rule, even with associated parameters. So that's really interesting here. If if WebKit filter is not supported for blur with 20 pixels, if supported, or if filter with blur with 20 pixels is supported, let's define that the blur rule is this one. Okay? And if it's not supported, then let's define that blur is just changing the opacity. From the point of view of the JavaScript developer will still apply the same rule, blur, okay? But the CSS filters will be removed and replaced by opacity thanks to @support. So we can give the control over, let's say, adaptability to CSS designer. That's really cool. That's really powerful. David, next demonstration about Flexbox.
Flexbox and source set. So let's move back to my mission.
Because we talk about adaptability. So.
Yes. So today you've seen that we are talking a lot about responsive design and more about adaptive design, which is more how to adapt the global UX to the current device. And when you're building some responsive stuff, you've got media queries, you've got a lot of cool new display like the Flexbox. But the problem you may have when you want to display some images is that you've got various definition of the resolution of the images for, let's say, for an iPhone using some Retina screens, for a classic phone, and for a PC. And you don't want to download all the images on the client side and to define through JavaScript how to choose the proper one. So it would be better to let the browser decide based on what is currently executing. So if it's currently running on a new Windows phone with a high resolution screen, I want to choose the specific version of the image, rather another one on the low device. So to do that, you've got source set being available. So it's very simple to use. So the first thing you need to use on the image tag is to use the classic source property you may have. So it's a fallback. So if the browser is not supporting source set, it's going to use this specific image. So let's do that by default. But if the browser is being able to handle this new property over there, you can say to the browser, please use this version of the image, X1, if the current DPI of the screen really match the CSS and the hardware ratio and pixels, then please use this image. So if, for instance, you've got a smaller screen, a smaller physical screen, but with a higher definition, you may ask to the browser, please use another version of the image, and you've got the point. You can go up to whatever you like based on those specific rules. So it could be very cool. Now, some of the guys, like myself, got some 4K screen at home, and we really want to have some cool website being displayed on that. So we can choose it like that. So let me show you this simple web page inside IE11. It's using the default image. And you can check that because when I'm going to use a new version of the image, I will put a specific logo on the top left on the image. So currently, IE has been using the default image of, it was a
blurry one.
A blurry one. It was a game we've been building with our game engine, so really cool. If I'm switching to Microsoft Edge, you can see that this is the very same image currently using the 1X version. But how to simulate now that I want a higher version? How to test that? So you need a phone or a specific device, or you can simulate that by using the zooming option of your browser. For instance, let's say that I want to simulate the fact that my current screen resolution is still the same, but I want to enhance the DPI by doing like that, and you need to refresh. And you see the browser automatically decided to take a new version of the image, and it has been downloading only this specific image. So to check that, we can, for instance, go on the F12 tools, find out the proper demonstration, should be this one. Dock that here.
No, that's IE.
And let's check the network. Let's refresh. And it wasn't the right one, so let's close IE just to avoid letting me.
You're really good at that, right?
Yeah, really good. Thank you to support me, David. And you can see that the browser decided to just load the proper version of the image. So you've been referencing a bunch of different images in your code. But the browser and the client decided to choose the proper one based on the current resolution and capacities. And even in the specification, it is specified that the browser could even choose to load the image based on the current bandwidth. So let's say that you've got a Retina screen, so you're pretty happy about that, but you've got a very slowed down connection. It's probably not a good idea to give you the high resolution image of that. So if the browser is being able to detect that, it will try to send you the low resolution of the image to have a speed website, a fast website. So we decided to use that. So I'm currently rewriting our website. So let's have a look to our Babylon.js website today.
This is free advertising.
Yeah. Maybe we will get into trouble. I don't know. So today our website is like that. So we try to mimic the modern UI stuff using some specific layouts, so we were pretty happy about that, but it wasn't scaling at all. So we are fairly good JavaScript developer. We are less good designer, and we decided to change that. Well, I decided to change that. For that, the new version I'm currently working on is this one. So I've been using media queries and Flexbox to be able to have some better site that's going to adapt itself to the current resolution. And the good thing is now I can mix source set, Flexbox, media queries to have some good experience. So if I'm zooming inside the website and now refresh it, you see I can enhance the resolution of the image, and I can even test that. So the design is not finished. If you're a good designer and you work for free, we are welcoming you.
Please send us a mail.
But if I'm running that on my phone, that should be somewhere. There it is. So I'm going to rerun that. You can see it. So this is the same website. And on the phone, if I'm turning it back, you can see I'm loading currently the 2x version of the image because the current screen resolution of my Windows phone is high enough to have the good version of the image. So you can test it on the device. So the good thing is that you can test it on Microsoft Edge on the desktop. And as David was saying, this is the exact same engine running on the Windows phone. So it's pretty easy to just double check that everything is working fine on your specific hardware screen. And then you've got a good experience like that.
Thank you, David. So get back to another demo. Yep. So we also, since i9, we supported SVG inside HTML, but the community asked us, and thanks to user voice that I will mention after, and thanks to the way we are working now, we hear the community, and they ask us, please support foreign object. So what's foreign object? Foreign object is the opposite of having SVG inside HTML. Foreign object is the capacity to embed HTML inside SVG. So in this way, you can have a SVG page. Let me show you. Yep. So here I have my HTML element. Inside my HTML, I have my SVG element, so a vector-based rendering. And inside this SVG, I can have what we call the foreign object here, where I can put HTML. So that's interesting because SVG is purely vector. The foreign object then will be controlled by this purely vector space, and we can apply any specific effect we can have for SVG. We can mix vector object and put some, for instance, text inside. We can use it to play like I'm doing here. I would like to show you the power of SVG using HTML inside. I will use filters. Again, it's not CSS filter this time, it's SVG filters. We support SVG filters, and SVG filters apply an effect on top of the vector rendered image, okay? This image will now include the HTML rendered image, and that's interesting because I can do things like this one. Here. This is what I call the drunken browser. You know, too much beer, you go home and you want to search something, and the word look like this one. Okay, let's search for Microsoft Edge. Yeah, remember? We all knew that. And the iframe inside my SVG is working perfectly well. There is no problem with that. And because I'm inside SVG, I can apply SVG on top of that and use my stuff. I have another thing I can do with that I wanted to show you. So instead of using that, I want to use just this one. Oops. Let's go back there. I forgot something?
Yep, the dash.
Yep. Thank you, David. Let's force a refresh. This one is the Minecraft browser. So, and what's interesting is that if I search for babylonjs.com, that's not easy. I have to remember to click here. I'm a Minecraft player, and I can take any 3D object, and this is HTML page using SVG. Inside SVG, there is WebGL with...
And it's running at 60 frames per second.
Okay, I have to admit that's just cool.
So we're not sure about the use case here, but,
Yeah.
but you get the point.
You get the point. You can use HTML inside SVG. That's cool. I'm pretty sure that your kid will love that. And then, very latest things we wanted to show you guys before moving to the Q&A is HTTP2.
So HTTP2, so it's a bit difficult to find something very visual to let you see what HTTP2 is. Well, HTTP2 is being built thanks to Google, what Google has been doing with Speedish. So Speedish, they try to build something new, different from HTTP 1.1, which is fairly old now. And we're using some mobile devices and all the new devices, we had some problem with the performance. So we tried to find some hacks to end that. So let's talk, for instance, about the number of requests a browser can send to a web server. So most of the time, by default, it was 4 simultaneous requests to the web server from a specific client onto a specific domain. So if you wanted to load, let's say, 10 or 20 images from this web server, from your client, you were only able to do it through 4 different requests, and you had to wait it. And if you want to change that, there was a hack being known by everybody, so you can have several domains, like CDNs, so CDN number 1, CDN number 2, CDN number 3 to 4, let's say that. And thanks to that, you were able to do 4 requests to the first CDN, and then 4 requests to the second one, etc., etc. But you were doing kind of a hacks because the browser had to do that. Plus the fact that you were forced when you do a lot of requests to add a lot of overhead on top of every of the HTTP requests to the web server. So writing HTTP2, it's now being handled by the IETF task force as a standard, and we're all working on that. So it's being implemented by Microsoft Edge and Chrome and Firefox. And the idea, I'm currently browsing a web page from a Google server. So they've been implementing it in one of their server stack. And you will see that the way to load the image is much faster for various reasons. First, we are being able to do some multiplexing on the streams. You're not forced anymore to send various requests on the web server. You can create a single request, and we're going to embed several streams inside this request. So we'll negotiate it only once with the web server. We're using binary encoding, also using HTTP2, so it's more light on the network. And we can also anticipate what you need on the client side. For instance, when you load an HTML page, we all know that there will be some CSS and JavaScript inside that. So it's a bit stupid to load the HTML page, and then, yes, I know this specific JavaScript file, then do another round trip to the server, get it back, and then I want this CSS file, etc., etc. So the idea is to let the web server say that you want index.html. Inside index.html, there is foo.js. So what we're going to do is the same request. We're going to send you back directly the foo.js to the client to save some time. So we can anticipate what you need. If the browser says, I don't need this file because I've already got in the cache, we lost a bit of time, but most of the time it will end the speed. So this is a web page done by Google that's really interesting because you can simulate what's going on. So let's load the page using HTTP1 and then 200 millisecond latency. You can see that this is currently being serialized. So I'm having several requests to load part of the image, and I cannot do it very fast because I need to go back to the server every time to load some new piece of the page.
And each request will have a 200 millisecond latency.
On the other part, using HTTP2, you see that I'm being able to have some multiple streams being rendered, and I've got a unique request on the web server to load all the streams, so it's much faster to load the image. And you get now the point. It's very visual because it's on the image, but think about that with all the parts of the web page you need to load from the server side, and you will have the same speed. So it's really cool to have that specifically on the mobile, on the Windows Phone 10 using Microsoft Edge, or every new devices you may have that got a modern engine, because it will really enhance the speed of the web page without doing anything for you. It's completely compatible with HTTP 1.1. This is the same commands, the same verbs. We just change the way to communicate on the protocol and on the stream and all the negotiation part.
Excellent. Thank you, David. So we try here to handpick some of our favorite features, but as I mentioned before, a lot of them are still inside the box. So the best idea for you, if you want to try it, just install the very latest version of the Windows 10 build. The Edge engine is here. So far, it's still Project Spartan, but just change in your mind and rename it to Microsoft Edge, and you get the point. If you want a feature, if you really want a feature, please use and give us your feedback on uservoice.modern.ai. For instance, here I capture asm.js. It was a huge ask for the community. Please support ASM.js. ASM.js is a way to compile C++ into JavaScript, and ASM.js will add some, some additional information for the garbage collector and for the JavaScript engine to enhance performance, okay? Unity support it, Unreal Engine support it, so if you are using Unity 5, you can just export your game to WebGL with ASM.js, and so now, if you just install the very latest version of Windows 10 and so of Microsoft Edge, you will be able to run WebGL games from Unity using ASM.js.
So you got it in the About Flags. So if you go on Microsoft Edge today, you type About Flags, and you are able to enable ASM.js inside Microsoft Edge.
And I show you another example here on the backlog. So people ask to show syntax error in the debugger. Fair. We put that on our backlog, and we indicate that it's on the top, and we hope to start it soon. So this is the new way for us to communicate with you guys and with the community. Let us know that you want something, and we will let you know that we are working on some, we consider others, and some of them are not really on our top priority list. Please evaluate the session, and now it's time for question. Yep. So let me show you how I can answer this question. I can go to modern.ai. So status.modern.
The question.
Oh, sorry. Yeah, please. Thank you, David.
The question is about template, HTML template. That's right. Are we working on it?
Are we working on it? So yeah, so far we are under investigation. It's part of a more bigger story, actually. The best thing you can do is to provide us feedback on user voice to let us know why it's really important for you and ask people to vote. That's the best way to communicate with us. But yes, we know it's really important, and it's under consideration. That's it. Yeah, that's sad. Some of the other parts can be easily polyfilled on the web component part, but I know this one is not possible. Other question? Yep. So the question is, how long are we going to maintain IE11? IE11 is part of Windows 10. So same life cycle as Windows 10. I have no idea for this. I'm so sorry about that. I can dig into our support stuff. Just ping me, and I find that for you. But IE11 will be supported as long as Windows 10 will be supported. It's part of Windows 10. Yes?
David, what's on your T-shirt?
Ah, that's a good question. What's on my T-shirt? So I keep this question. I just want to be sure. Is there any other question?
Yep.
Yep.
Yes. The question is Microsoft 10 will be Windows 10 only? And the answer is yes. Yep.
Yep. Most of the time, if you are in the About Flags, I think that Kirill is here. No. Yeah, so it's a good question for you.
The question, can you repeat the question?
So the question is, some of the features are under flags now in the Microsoft Edge, so I have to go to About Flags to enable them. If I'm using Windows 10 WebView, can I use, for instance, ASM.js? I was pretty sure, but I just wanted to.
So the answer is?
No.
Yep, the question over there, first floor.
Yes, we are working on implementing WebDriver into Microsoft Edge.
Yes?
Are there any specific guidelines for performance when writing extensions for Microsoft Edge?
Extension, you mean JavaScript extension, right? So far, I have I cannot answer this question because it's really too early for us. We really did a demonstration yesterday. No, it was 2 days ago during the keynote. It's possible. We are working on that. But everything related to performance and things like that, we are too early in our development cycle. Hopefully, no, clearly.
And if there are anything specific, then they'll come out at least a few months before the November timeframe? Is that fair to assume?
I don't know. I'm so sorry, but I don't know. It's a different part of the engineering team, so I don't want to say something wrong, so I don't know. Yes?
So the question is CSS filtering is working with CSS transition?
I tested with transition, so yes. And for animation, I don't see any reason why it should not. I'm pretty sure it is. I just checked, but 99% it's okay. And I see that Jacob is saying yes. So it's a 100% yes. Yep.
For the app support rules in CSS, is that a W3C standard?
Absolutely, sir. Absolutely.
Do you know how widely that's supported in other browsers?
I know that it's reported in Chrome. Or we can go to Can I Use. Do you know this site?
I'm just looking up on Can I Use and it's not there.
It's not yet in
Yeah, it's
Can I-
not yet? So yes, it's supported. Firefox, Chrome, Edge, wonderful. We live in a wonderful world. Oh, no Safari. Interesting.
No one uses that anyway.
Yes?
WebSocket? Yes, sir. And that's a good transition. Thank you. Because what I have on my shirt
Yes.
is based on WebSockets. So if you want, guys, we have just 4 minutes. If you have any other question, please feel free to ask us right after. I just want to show you what Volant.js is. We announced that yesterday.
So let's explain what the project is. We decided just after Babylon.js to work on a new framework. So we love writing new frameworks to help developers. But apparently, not all developers are WebGL developers. So we discovered that recently. And we decided to work on a framework that could help more developers than just WebGL. And when we were writing our own code, we found out that it was so complex to debug it on all the mobile versions. So when you write it, some code, you want to write it once and run it everywhere. But then if you wanted to run it everywhere, you need to debug it everywhere. And the problem is that there is many different tools to do that, but no tools that were running really everywhere to help us. So we decided to write a debugging tool framework to help you doing that, and only based on pure JavaScript, CSS, and using a Node.js server on the backend to enable real-time communication using WebSockets.
So here I have a Node.js server. I just do npm install Volant. That's it, nothing more. That will run and provide me a dashboard. The dashboard is here. I can go just locally to my dashboard. It will wait for any connection using WebSockets, for instance, if it's supported, or using polling with Xhatcher if it's not supporting. We are using socket.io to do that. So that's perfectly, that works almost everywhere. That works on my fridge. So I have a demo here just for that, especially for that. And I just want to show you this demo. Let's open it here. And I have this one. So we introduce Preserve 3D support inside Edge as well. So we have the way to do this kind of really cool stuff. I'm trying to reproduce what we have now on my XBMC media player. That's pretty cool. And if I don't have Preserve 3D, it's just flat. Okay, so this is just a demo I want to debug, because I can know that this demo is not working on a specific device. That's not easy to know if I'm using a phone. Oh, I don't understand why it's not working. So this way, what I can do is just add in my code here a reference to HTTP localhost. So my server is running on this URL, and I just want Volant.js. That's it. You don't need anything more. Crap. You don't need anything more.
But you need to type it correctly.
Yeah, and I'm not really good at that, right?
Yeah. This is the most difficult part. We still try to fix that to help you.
Sounds like, oh no, it's not good because I forgot this one. Yeah, thank you. Yeah, it could be long for me. And then, going back here, I'm reloading this page, XXYY, okay.
And go on the dashboard side.
I forgot something, but let me check that here. And I have, so I'm working on UI analysis tool, so please don't consider the iPhone stuff here. Yeah, I'm just trying to analyze the user agent string sent by the client, so I want to say, hey, it's an iPhone or whatever. I'm just working on that. So here, by just clicking on my client, I can see that I have my DOM. So this client could be on any device that can reach the server. So if you want to use it publicly, you just have to put that on any server on Azure or whatever. It will work. And you can see that you have your DOM here. You can obviously click on any element to see, oh, yeah, okay, I see you are using this stuff. By selecting things like, let me find a GUI, for instance, you can then have a red rectangle around the selected item so you know where you are and what you are working with. And you also have the console here. The console is really important because if something is crashing on the device, it will send some messages on the console, and the console will send all the message for you back to your dashboard, so you know what's happening. And I wanted to show you also third plugin here. We are using Modernizer on the device to know all the feature capabilities of your device, send that back to the dashboard so you can know that, okay, this specific device sounds like it's supporting, for instance, CSS Transform 3D or Preserve 3D or whatever. We have all the list here, and I'm pretty proud to show that it's all green with Edge. That's cool. Oh, no, we are not supporting SQL database, but that's okay. That's all one. You can also here add order or whatever. You can just say, I want to execute something here in my console, and this will be executed on the client. So you can control this kind of stuff. You can do that. It's free. Please use that on any of your debugging stuff, and we are open to any contribution. So
It's open source.
Yeah, David will add a web audio plugin to allow you to show the node and to display the node web audio stuff. We think about connecting to debug node as well. So for instance, you are running on Firefox OS. There is a debug port where we can connect to know where we are in the code and probably put some breakpoint perhaps in the future. So it's a really open infrastructure. It's really helpful because most of the time when we're dealing with mobile devices, Cordova application, anything that it's really hard to debug, this provides the very first aid kit. Thank you all for being there. I really appreciate it. Don't forget to evaluate. Thank you, thank you. Merci.